we've been learning different reasons. So far, we have learned these three reasons: angles around a point, angles on a straight line, and vertically opposite angles. So what we're going to get to today is looking at parallel lines. And then we have a couple more lessons that we're going to have a look at, sort of just revising all of this stuff and making sure that we're happy with these angles and straight lines. So what we're going to just start off with is a little bit of a recap of what we've already done. In our last lesson, we were looking at vertically opposite angles. And so let me maybe do it like that. I've got two questions here. There are three, but we'll get to the third one in a second. I've got two questions here where I'm asking you to solve for an unknown angle. So let's have a look at the very first one together, and then we'll have a try, and then you guys can try the second one. So guys, remember, three different reasons that we've learned. I'm just going to write them above my vertically opposite. I have learned about, whoopsie, so sorry, angles. Okay, we're having some technical difficulties. There we go. Angles.
It will get there.
Ay, ay, ay. Okay, I'm getting there. It'll all happen now. Okay. Haha, right. Angles around a point must add up to 360 degrees. And we've learned that angles on a straight line must add to 180 degrees. So these are the three reasons rather that we have learned so far in this course. And we have obviously learned this third reason of vertically opposite angles. So I see some awesome answers already coming in on the chat. If I look at question one and I'm asking you, what is the size of that X angle over there? Well, I can see that I've got that very nice cross shape that we know that we look for when we're working with vertically opposite angles. And we know that the angles opposite each other in that shape are then equal, which means that X and 85, oh no, I just took it all away. X and 85 are equal in size to each other because they are vertically opposite each other. They are directly opposite each other at that point of intersection between my two lines. Now, guys, remember, when we write down our answers, we always have to give a reason for a statement. So in this case, I'm saying that X is equal to 45, and my reason is vert op angles equal. Now, remember, if your reasons look a little bit different, that's not the end of the world, but as long as your reason is saying that vertically opposite angles are equal to each other, that's absolutely fine. Okay, so nice, easy one to get started off with.
Yeah, I was thinking that everyone take a screenshot, okay? So these three rules is what you need to remember. So a screenshot, because it's what we're gonna use with the one that Teacher Sam is gonna teach us. So if you haven't written it down yet and you don't have a cheat sheet, they call it, eh? So this is a very important cheat sheet. So you better take a screenshot of it, okay, my babes? Let's do that. We can nail it. I can see answers on it.
Oh, alrighty, guys. So let's have a look at question 2 here. Again, I'm asking you to find two unknowns, an X and a Y. So you can start wherever you want. But as Yolanda's just said, we've got three different reasons that we can actually use here. So I'm going to give you a second to try and come up with an answer for X and for Y for me. You can put your answers in the chat. Just remember you label X equals and Y equals, right? For those of you that need to go back to the first question, there you go. You can now see both, and you can see the reasons that you could potentially use.
Okay, my babes, let's do this, guys. Let's show Teacher Sam that we can do it. I see Tejo, I see Nkulumo. So I think your hand was up first. So I'm gonna give number 2 to you. I see Enke also. And these are my new people. Some of them, they're my new people. So
Nice,
so everyone, so you remember you are giving it a try, right? Everyone, you can give this question a try, put your answers of what you think it is on the chat, and then we're just gonna go to Tejo, and Tejo is gonna teach us on how Tejo achieve Y or X, and we can go to Nkulumo also. So let's go. Teacher Sam, are we ready to give the answer?
Let's do it.
Okay, cool. Sejo, we are all yours.
Hello, ma'am.
Hi.
Actually, I'm not answering.
Okay, do you have a question?
Yes, I have a question, ma'am. Ma'am, what does the op stand for at number one?
Opposite.
Thank
Yeah.
you, ma'am.
So in our geometry reasons, guys, we can abbreviate certain words, and that's why I've always written the reason out for you so you can see what you can abbreviate. So vert is vertically and op is opposite. All righty.
Thank you.
Good.
Okay. So we gotta go to Nkulumo. Nkulumo, I hope you're helping us out.
Yes, ma'am, I am.
Awesome.
Ma'am, the answer for Y is 45 because they are vertically opposite.
Awesome.
Let's go. Well done.
And I love that we are automatically giving our reason. We have to remember those reasons. Okay, vert, op, angles equal. So guys, just so that we're clear, we've got our cross shape. The angles directly opposite each other are then equal. So exactly 45 and Y are equal in size to each other. Good, well done.
Nkulumo, would you like to try X, or should I give another person
Yes.
a chance?
Ma'am, I'd like to try X.
Awesome,
let's
that's what I
go,
like to
girl.
hear.
You say 3x plus 45 is equal to 180.
And what's your reason?
Because they are adjacent angles
And what are they on? They're sitting on a?
on a 180-degree line.
Woohoo! Right, exactly. So these are angles on a straight line. Awesome. Well done. Keep going.
Oh, you did it.
And then you say 3x is equal to 180 minus 45.
Good.
I'm just working out here.
You're doing good. You're doing good.
And then the
Nkulumo.
answer is 135.
Good. And then how do I get that x alone?
You say 3x over 3.
Yes. And what do I do to the other side?
You say 135 over 3.
Good. Well done. And so what is 135 divided by 3?
It's 45.
Awesome. Well done.
You nail it. Well done, girl.
Okay, guys. So exactly what we see there for angle X is that it is on a straight line. So we know that when we add 45 and 3x, we must get 180 degrees. So that's why we have our equation set up with our reason angles on a straight line, and then we can go and solve for x. That was really nicely answered. Well done.
Well done. I just want to check if Nomi, if you wanted to answer, then you can lower your hand down. But if you wanted to ask a question, keep that hand up, okay? I'm just gonna come to you and see if that's a question or you wanted to answer. Hi, Nomi. Okay. So I see Londega, probably this is a question because I just saw your hand now. I'm gonna come to you. Londega, do you wanna ask your question?
I really wanted to answer, but then she already answered, no problem.
Oh, Londega, the next one is yours, okay? So keep your hand just up there. Keep your hand.
Okay.
Okay. Okay, so guys, remember, this is just revising what we have already done. So if this is a little bit new or if you're feeling a bit overwhelmed, remember to go back and rewatch those videos on Watobe's website, alrighty? Okay, so take your screenshots of this and let's do one more revision before we have a look at our parallel lines. Okay.
Oh, okay. So Nomi has spoken on the chat, and they're asking if we can go a little bit slower. So Nomi, I think Teacher Sam is what she has mentioned already, that we have done these rules before. So on the new rules, we're gonna go really, really slowly. Okay, I hope that helps.
And guys, please, like, if you want to know what has been covered, go onto the website and have a look there, okay? Because all of the videos will be there. So if there are sections that we have already covered and you maybe missed, then at least the videos are there for you and you can sort of watch them in your own time as you go along, okay? So it's all on the website. You can have a double check there. Okay, so we have got question 3 over here. Again, what I'm looking for is the value of X. So I'll give you guys another minute or two, and I would like you to tell me what X is equal to. And I can see Ntlekos asked if they can do this question. So I'm going to say yes. If Yolanda, you are happy with that. And I see the hands already
Yes.
raised.
No, I'm always happy with the answer.
Awesome.
Always.
Okay, we'll give everyone a second and then we can have a look. Guys, remember those reasons. We have to have reasons in geometry. That's really, really important. I'm seeing some great answers on the chat. Well done, everyone.
We can do this, my pips. Let's try it.
Okay, Ntleko, are you ready?
Hey, let's unmute Lego. Lego, wow us. Teach us. I'm listening.
So, ma'am, I got the answer as 50 plus 90 is equals to 360 degrees.
Okay, so why are you, just sort of walk me through what you're doing. Why are we adding the 94 and the 50?
Because it's angles around a point.
Okay, so I agree that there are angles around a point here, but then we need to remember that we have to add all of those angles. So we need to know that angle there and we need to know that angle there.
Yes, ma'am. I mean, 94 plus 50 is equals to 360 degrees because there's a point here and there's no straight line. The 9 is equals to the straight line by the x, not by the straight line that leads to nowhere.
Okay, but the thing is, if we're going to use angles around a point, it has to be around the central point. So we're adding all of the angles up around that point. It has to form a circle for us if we're going to use angles around a point. And I see now I've just done that. So what I'm saying is that we can use angles around a point. That is okay. But the problem is that I've got some unknown angles there. I have this angle over here that I don't know, and I don't know that angle. So if I work those two angles out, then I can do angles around a point. But 94 plus 50 can't equal 360 because that's not all of my angles around that point. Does that make sense?
Yes, ma'am.
Okay, so if we have a look at what we have, and like I said, we can do angles around a point. We just have to do a few more calculations before we do that. So does someone else maybe want to have a go? I see lots of hands. Yolanda, who shall we ask?
I see them. So I think I'm gonna go to Tilly D. I'm gonna come to you. Trying to spread the love. Tilly D, teach us. We are ready. Okay, Tilly D, you can unmute on your side. Okay, so Tilly D, you can also put your answer on the chat. Okay, I'm gonna go to Palesa. Palesa, can you unmute on your side so you can teach us, girl? Let's go.
Yes, ma'am. How are you guys?
We're good.
Hi.
So, ma'am, what I did, I said x plus 49 plus 50 is equals to 360.
Where did you get 49 from?
Ma'am, from the question.
94.
Yeah, 94, I mean, ma'am.
Okay.
So,
Okay, so now,
ma'am. Yes, ma'am.
so remember,
And
we're
then
not, we can't use angles around a point here because remember, I don't have all of the angles. I need to know that angle and I need to know that angle if I'm going to do angles around a point.
Okay, ma'am.
Okay,
So, ma'am, then
yeah,
yes.
no, keep
Then,
going.
ma'am, I said x is equals to 360 degrees minus 144, because when I say 49 plus 50 gives me 144.
Okay, so guys, again, we can use angles around a point here. That's not wrong, but you are missing information. So we can't just go straight away and use 50 and 94. That's not angles around a point as it currently stands. Just want to get rid of that.
Yes, ma'am.
Right? If you're going to do angles around a point, and I need you all to just stop and listen to what I'm saying now because we don't want to repeat this. If you are going to do angles around a point, you have to add all of the angles around the central point. So all of those angles, 1, 2, 3, 4, 5, have to be added together to give me 360. That's fine, but then you first have to work out that angle, and you then have to work out that angle in order for you to go and work out or use angles around a point. Okay, so what we are going to do for this question is we're going to look and see, well, what else do I have that can maybe help me? Well, what I can see is that I've got a cross. Okay, which means that this angle of 94 is equal to that angle of 50 plus x, because those angles are vertically opposite to each other. And so what we can say is that x plus 50 degrees is equal to 94 degrees. And my reason is they are vertically opposite angles. Then I can solve for x by saying 94 minus 50. And I get that x is equal to 44 degrees. Okay, so that is how we need to go and work out x here. Well, you can use angles around a point, but then you first have to go and work out this angle over here that I'm labeling A, and you have to work out this angle here that I'm writing B. That's the only way you can do angles around a point, because you have to have all of the angles around the point. Okay.
Yes, ma'am. Yes, ma'am.
Cool, well done. Okay, guys, if your hands are still raised to answer the question, you can put them down. If you have a question, though, please remember that you can put it in the chat, just in case we don't get to it all.
Yeah, guys, I'm here on the chat, reading the chat and responding to people. So I'm here to help you. So if that hand is to ask questions, let it remain. But if it's to answer the question, please lower it down. Okay. And Keko, if you can hear us, so if you don't understand, you can just tell us exactly where don't you understand, and that will help teacher Sam and I to know exactly where you're getting lost. Okay, so Bongokuhle, I am on your case, so you can ask your question, and the rest of you, please put the questions on the chat also. Nhleko, I see you, you can put your question on the chat. And say, I can see you, you can put your question on the chat. Bongokuhle, you have to unmute on your side so you can talk to teachers. Oh, Bongokuhle disappeared. Okay. Nhleko, so we are all yours. You can ask.
Ma'am, I don't understand when you said x is equals to 94 degrees minus 50 is equals to 44 degrees. That's
Okay.
where I don't understand.
So I'm just using vertically opposite angles. If I go back to my diagram, and I've just seen something on the chat, guys, just because something looks like it's 50 or 40 or 90 does not mean it is. I either have to tell you its size or have to show you its size. Otherwise, you have to work it out. So just because these two angles might look equal, you can't just assume they're 50. You need to go and actually go work it out. Right, so for this question, just ignore the y. I'm not going to keep erasing it. The y is not supposed to be there. Right. For this question, what I see is that I've got that nice cross shape that I like when I'm working with vertically opposite angles. So what that means is that this angle of 50 and x, so that whole angle together, is equal to 94 degrees. Those are vertically opposite angles, so they must be equal to each other. What that then means is I can set up my equation. So that's why I said, okay, well, x plus 50, which is what I've got here, must be equal to 94 degrees. So I've set up my equation using my reason. X plus 50 equals 94. And then I go and solve for x. I go and sort of subtract 50 on both sides so that I can get x alone. And then when I say 94 minus 50, that is where I'm getting 44 degrees from. And so x is equal to 44. So I'm just solving my equation. Yeah, sorry.
Ma'am, the way my math teacher does it, ma'am, he says x plus 50 plus 94 degrees is equals to 360, and then he adds 50 plus 94, and then he gets the answer. And then he says that answer minus 360 is equals to the answer.
Okay, but again, I can't use that here. This is not angles around a point. That plus that does not equal 360 degrees. If I said this angle plus this angle plus this angle plus that angle plus that angle, then I can use 360 degrees because there's my circle. But just using the 94, the 50, and the x, that is not equal to 360 degrees. So I can't use that here. If you go, so if I told you that this is 86 and that's 86, then you can use angles around a point because then you've got all of the angles and you can add them together. But because I'm not working with all of the angles that make up the circle, I can't use angles around a point here. Okay.
Yes, ma'am.
Does that make sense? So just make sure that if you are going to use angles around a point, you have all of the angles.
Yes, ma'am.
Cool. Well done.
Nice. So Lefika, is Lefika here, guys? I'm just looking for Lefika. Lefika, if you are here, shout out to you. You can raise your hand. Lefika Teto Lefika. I'm just giving a shout out to you. We just want to see where you are so you can raise your hand. But if not, teaches them, we can continue.
I see Lefika's raised their hand.
Oh, Lefika, so this next one is going to be for you, okay? And hello to you. Special shout out to you, Lefika.
Okay, guys, just quickly, I see just on the chat, how do we know that we have to minus or add the angles? That is just solving the equation. This was minus 50. So to solve my equation, I use inverse operations. So I have to minus 50. That's going back to the equation stuff. We have done equations. So there are videos on Watobe's website for equations, but it's basically just solving an equation using inverse operations. So if you need to recap that, go and have a look at those equations videos, okay? Alrighty. Take your screenshots if you need.
Screenshots, my people. So guys, it will help to actually go to the equations and just try and learn how do we solve for x when we have that number, what is the opposite of a plus and the division and all of that, okay? So Lefika is ready for us, guys, for the next question.
All right.
Mpo, that's okay, Mpo. Guys, if you don't understand, remember that if you just joined us, we've been doing these things like, you know, since last week. So it means that you need to catch up. You need to go and watch all the videos that are on this series of geometry for you to actually understand fully, because we only have 1 hour. So teacher Sam doesn't have time to go back and go back and go back. And we love you all. So we hope that next week you will have revised everything on this so that you can understand more. Okay, all the best. Let's do this. Let's continue.
Okay, so we are halfway. So let's take a quick break because we haven't actually started anything new that I wanted to do today. So we need to get on that. But let us just have a quick little break. If you do the brain teaser, brain freeze, brain break, that's cool. But just get up, stretch, get ready for our parallel lines, which is what we're going to be doing now. Your brain freeze, brain train, whatever you would like to call it. I feel like I used brain freeze last time. Let's change this. Is basically to guess the phrase. If you do it, you do it. If you don't, you don't. That is absolutely fine. But just make sure you are getting ready for our next half an hour.
Okay, guys, let's stretch wherever you are. Stretch. And let's do this. Let's do this, my people. This is a brain train. Guys, Teacher Sam is cheering us up. It's a brain train. Remember that you guys gave all these names. So to our newbies, we give our brain break names, okay? So in this class, we have so many names. But today, we're using brain train. So all congratulations to the person who came with the brain train. So I hope you guys are figuring out what's going on here, okay? Give this a try. Hey, Skia! Congratulations. Teacher Sam has selected your name. Okay, Emife has, Emife, do you have an idea of what we're doing? Or Emife's hand disappear?
Okay, guys, you can pop it in the chat if you want. Basically, you have to find the like phrase. So for example, I don't want to like give anything away, but if we just look at the first one, this would be right between, the eyes.
Oh my word, that's awesome. I didn't see that. Guys, do you see it? That's right between the eyes. So the tick is the right, and then it's also in between the eyes. That's awesome. That's really awesome. Okay, Gia has something for us.
Hello, ma'am.
Hi, Kia.
Hi.
I'd like to try number 3.
Okay, tell us.
How about an amazing job?
Where did the amazing come from?
Oh,
I like it definitely could be, but what I was thinking is an inside job.
oh,
Yeah, exactly. And inside. That's hilarious. I found it so funny. Oh, okay. So Hleko has one for us also. Hleko.
Awesome. Let's hear it.
Hi, Hleko.
Hey, ma'am.
Hi.
You can try. Try number 4.
Number 4 is undercover cop.
Awesome. So under cover cop.
Funny. Anyone with number 2, guys? Anyone with 2? Have we seen it in the what you call it, in the chat? Maybe someone has put in the chat. Let's try, my people. Let's try so we can get back to bed. Oh, these are funny. I find them, all of them funny.
Oh, Matthew, well done. Fork in the road.
Yeah. Well done.
Right. Reason because is there's the word fork and there is the word road. There's fork in the road.
Oh my word. These were all funny.
Well done, guys.
Well, while we go back, I'm just gonna shout out to some people. Sarah, I see you. There you go. You're like, you know, I don't know whether this brain break was just crushing your head. Grandma Maseko, shout out to you. Tolelo Ndlakuvu, shout out to you over there. See you. Let's hope that we can answer these questions, guys. Let's go.
Okay, guys, so just for the brain break, just like it's not something you need to stress about. It's just something fun that we take a little break from math. So if you don't quite get it, or if it took you a bit longer, trust me, I can't do these. I have to Google all the answers before I put them
Me
up here.
too. That's why it was so funny to me, because I'm like, what?
So it's just a little break for you. Alrighty. So let us have a look at what we wanted to chat about today, which is parallel lines and the relationships that they create. All right, so this is just a little diagram, firstly, to show you how we will symbolize parallel lines on a diagram, and just to sort of make clear what a parallel line is. So very importantly, parallel lines are lines that will always stay the same distance apart from each other. So hopefully the maths joke now makes sense. Parallel lines have so much in common, it's a shame they'll never meet. If they have to stay the same distance away from each other, there's no way that they can ever intersect. So
Exactly.
smart math jokes.
That's
So
really
that is
fun.
what a parallel line is. And what's quite cool with parallel lines is because of the special relationship that they have with each other, they create some interesting relationships with angles. Okay, so the first thing that I want to sort of point out to you is how we indicate on a diagram that lines are parallel. When we are working with that, there are little arrows that we put on. So I can already see somewhere in the chats, people are starting to put the parallel lines. I will put on arrows to show which lines are parallel to each other. Now, those arrows basically show that they are traveling like at the same distance in the same direction as each other. And so those lines are then parallel. If I have multiple sets of parallel lines, all I do to differentiate them or to like tell them apart is I would put two arrowheads on. So what I can see here in this diagram is I've got two sets of parallel lines. One is AB and CD, and that's with my one little arrowhead that I've indicated that. And then my other set of parallel lines is then EF and GH, and that I use two parallel lines so that I could sort of separate them from the other pair of parallel lines. Okay, guys, I see a lot of I'm confused on the chat. We've just started this, so don't stress too much. But if you are confused, please try ask a specific question, as Yolanda was saying earlier, just so that we can know specifically where to try and help you with this. So all I'm doing right now is explaining what parallel lines are and how you will be shown that on a diagram. Okay. If I want to go and write down which lines are parallel, the symbol for parallel lines are two sort of slanted lines next to each other. That's the symbol I use for parallel lines. So what I can say here is if I look at my green lines, the line AB is parallel to the line CD. They run in the same direction, they're the same distance apart. And I can say that EF is parallel to GH. So that's just like a notation thing. If I'm going to talk about parallel lines, this is how I write it down. I write it down with a little symbol and I say which line is running the same distance apart in the same direction to which line. And I've highlighted those for you on the diagram. Okay. So guys, parallel lines are lines that run equidistant or the same distance apart from each other and sort of follow the same direction. They've got the same slope as each other. All right.
I just want to calm everyone down. Guys, this is new work, right? And remember that Teacher Seb hasn't even given us an example yet. So don't worry. The more we do example is the more that we're going to get and understand things and everything will be clear, okay? For now, you just have to like look and learn and then you will understand as we go, okay? Okay, my people, you got this. Let's do it.
Yeah, so guys, exactly, like as Yolanda says, like all I'm doing here is just showing you what a parallel line looks like, because now when we start looking at examples, we actually need to know if I'm working with parallel lines. All right, so what we are going to essentially start looking at are three different reasons that we use when working with parallel lines. Now, the reason I've put them all together is because this is how I actually remember it. I remember parallel lines as fun. Some people use fuzz, which is cool, but I use fun. And that's how I remember my parallel lines and the relationships that they create with angles. So as I said when I started, parallel lines like form very cool relationships with certain angles. And depending on the parallel lines and sort of the shape that you find in your diagram, we've got different relationships. So if we have a look at the very first one that we can work with is what we call corresponding angles. Now, corresponding angles, and I just want to get a better system going on here. Corresponding angles are angles that are formed when we sort of see an F shape. Now, the F doesn't have to look like a perfect F. I can have an F upside down and backwards. I can have an F that's super slanted like that. But as long as I'm working with parallel lines on my diagram, I have this relationship with the angles. Now, the angles that we're talking about are basically the angles that form between like the, I don't know what you call them, like the arms of the F. And so what we're saying here is that if we have two parallel lines and then another line that cuts those parallel lines, the angles that are created are equal to each other at like the armpits of the F. I don't know what that is called. So they are now the F's armpits. Okay, so we are saying that those two angles are equal to each other. That is the statement I've made over here. Remember, this is how we write angles. That's the notation that we use. So just to clear it up, I'm going to take off my scribbles. Angle BAC, if we follow from B to A to C, that is this angle up here. And then angle DCF, follow D to C to F, that is this angle over here. So those two pink angles that I've colored in are equal to each other. Okay, so that's the one reason that we need to know. I've seen on the message as well, that line that sort of cuts those parallel lines, so this line AF is indeed called a transversal. Well done, that's a very good knowledge of terminology within this section. I'm just not overcomplicating it, but it is indeed a transversal. So that's the first sort of relationship we have with our parallel lines. Our reason, remember, in geometry, we always have to have a reason, will be corresponding angles. So that's what that corresp stands for. Angles, we can use a symbol. And guys, really, really importantly, whenever you work with parallel lines and the angles they create, we have to state which parallel lines we're working with. Right? This is because often we can have more than one set of parallel lines and they can form slightly different relationships and work with different angles. So we always have to state which parallel line pairs I am working with. Okay, so that's really important. So that's if those are corresponding angles. When we start doing examples, that'll become a lot clearer. The next relationship that we need to be mindful of is the U. Now, this is what we call co-interior angles. Now, what's quite important here is that these angles aren't equal, but rather when we add them together, they are supplementary or they add up to 180 degrees. So when I take this angle here at BAC and I add it to this angle here at DCA, I must get 180 degrees. So those are co-interior angles. That's what co-int stands for. And again, we state which lines are parallel that we are working with. Right, the final one that we then go and have a look at is alternate angles. So this is now the N shape, as you can see here, and we're saying that this angle up here is equal to this angle over here, and those are alternate angles. And again, we state our parallel lines. Okay, so that's a lot of information. Let's just have a look at this very first one, this F1 over here. We'll come back to the others, so don't stress. If we go and have a look at an example of our F shape, okay, just F. So corresponding, what I'm going to do is I'm going to draw that little rule that we had. So there's my F. We have parallel lines, and we said that the angles sort of in the corners of the F are equal to each other. So looking at this diagram, what I want to try and do is I want to try and see if I can find that F shape. Okay, just let's see if I can find it. That would be the first thing I do. Now, what's quite important here is we can see that we've got these arrows on the lines, which means that the lines are parallel. So that's quite important for us. I know that AB is parallel to FG. Now I want to see if I can find, like I was saying, that F shape for ourselves. There's lots of different Fs, and this will happen in many diagrams, but let's see what we can find. So one F that I can have a look at here is like this backwards facing F, which is cool. It's telling me that this angle is equal to this angle, but that's not working with anything that I want. Remember, what we're trying to do here is we're trying to find the value of X. That's why there's an unknown X there. So let's see if we can find another F. Well, we've got an F over here. Yeah. And we can see that we've got this angle illustrated for us here. And we know that that has to be equal to the angle in the line above it. So it has to be equal to F. And so what we've seen here is that through corresponding angles, X is equal to 110 degrees. And remember our reason, corresponding angles. And we always state the parallel lines AB parallel to FG. Those are the ones I've drawn over in red over there. Oh, alrighty. So guys, we look for the shape. We looked here for the F shape, and then we tried to see, do I have any angles here that I can say are equal to each other? And we could see that because of the F shape and moving that onto my diagram, I had 110 is equal to X. Okay, I'm going to give you a second.
Take screenshots, my people. Take screenshots. Remember that you're going to get this. Slowly, slowly, you will get this, okay?
Okay.
So those hands up there, I'm not sure whether it's to ask a question, but Teacher Sam has explained it so nicely. So I'm just going to check with Ntabi Singh. Ntabi Singh, what do you want to ask on your side?
Ma'am, hello, ma'am.
Hi.
Hi.
Ma'am, I just wanted to answer there because actually you started by saying the F is A and F. So like I wanted to answer to tell you that the F is B and G.
Okay, thank
Well
you so
done.
much, Tabise. So every single hand that is up to answer, there's actually, the question is already answered. So I only need hands that are up to ask a question if you think you didn't understand, which actually is going to be rare because Teacher Sam has explained it nicely. So again, if you are raising your hand to answer, you need to lower your hand, okay? But if it's to ask a question, I'll give just one person for now because we're running out of time. So NK, I'm going to come to you. You can ask, and those on the ones that are raising their hands, you can actually put your questions on the chat, okay? NK, go ahead.
Hey, ma'am.
Hi.
Ma'am, I actually wanna ask you that, right, you said you took the X from that top corner over there, and then you said X, yeah, that one, this one. And then you said 110 degrees, and then the B and G one.
Sorry, you cut out on the last bit.
B and G.
Yeah.
Yeah, ma'am, like where, like, how did you find the answer?
Okay, so guys, what's really important is that B and G are just labels for points, okay? So if I just take my scribbles off here, point B is this point at the end of the line, and point G is that point at the end of the line. The same thing for A and F. So if you weren't here for our first lesson, go back and watch that video, but that's how we label lines. That helps me because I always have to state which parallel lines I'm working with. And we have to put that symbol there between the two because that's telling me that they are parallel. I saw that somewhere on the chat. So yes, we do need to put that symbol there. It tells me they're parallel. So I'm not necessarily using B or G in my working out because that's not what I'm looking for. Those are just labels. I'm looking for the size of X. And in my diagram, I can see this F shape is formed, which means that this angle X is equal to this angle of 110, because we know in the F shape, those angles are equal to each other. Does that make sense, Entle?
Yes, ma'am, it does make sense. But if there is no number and there's only letters, how are we gonna do it?
Okay, so generally speaking, there should always be a number somewhere that we can eventually go and work out whatever value we're looking for. If not, we would just write it in terms of whatever we've been given. So for example, I'm just gonna move away from this here. Let's say, for example, I'd given you a diagram like this, and I'd said something like X and Y. The only thing you can actually state there is that X is equal to Y because of corresponding angles. So if there's no letters, that's not the end of the world. You can just work with what you've been given, but there should always be some numbers somewhere for you to go and work out the unknown.
Okay, ma'am, thank you.
Pleasure. Okay, so let's just completely change up what we're doing here. You can ignore everything there. Let's have a look at this example over here. All right, so guys, what we are looking for, just ignore everything else. Think about the F. We're looking to see if we can find a shape F here. Now, if I look at my diagram, there's an F on its side. And we know that whenever we're working with that F shape, the top angles are equal to each other. So I see some hands already raised. Do one of you maybe want to tell me what X should be equal to?
Okay, we can go to Uratile. Uratile, let's give it a try.
Hi, ma'am.
Hi.
X is equals to 76 because it is corresponding.
Wonderful.
Well done.
Okay, so
Okay.
X is equal to 76 because of where that angle is sitting. And then guys, remember your reason.
Yes. So everyone who's putting their hands up to answer, please lower those hands down because we already answered. Anyone who has a question, then you can just let your hand remain there if it's a question, okay? But if it's to answer, please lower it down, okay? So I'm gonna take Nomi. Nomi, it looks like you want to ask a question. You can go ahead, Nomi. Okay, Nomi, because of the time, you can also put your question on the chat, okay? Like this, teacher Sam can continue. There we go. Nomi, hi.
Is it always hi? Is it always necessary to put the letters that are corresponding?
So like what I've written over here.
Yes.
Yes, we do need to always write that. We always need to say which parallel lines we're working with, especially when we have more complicated diagrams. There might be lots of different parallel line pairs. So I always need to say which ones I'm working with so that whoever's marking can make sure that you're working with the correct ones.
Okay, I understand now. Thank you, ma'am.
Cool, awesome.
Okay, so we have Nandi with the question. Go, Nandi.
Good morning, afternoon, ma'am.
Hi.
Miss, I want to ask that is the 76 always going to be the answer if it's standing like this?
I mean, it depends on what the number is. So this number can be any number. So if that had been 23, then that will also be equal to 23. But the point is that they'll always be equal to each other.
Oh, now, miss, thank you. I understand now.
Awesome. Cool. Well done. Okay. Guys, I know it's quiz day. I'm fully aware of that, but I'd like you to try one more. And if I don't have one more, I'm just going to draw one. Okay. So let us try. I have to now be creative here. I'm not an artist. I apologize.
Nhleko, we can see you there. It's just because we run out of time. So you can just do it on your book and give an answer on the chat, okay? So remember to give a reason, and also to make sure that on your reason you are pointing out which ones are parallel, okay? So those of you that are raised their hand, if it's to answer, I think we are really straight because the Gisem has to go. So the Gisem will explain this one for us.
Okay, so guys, if we have a look here very quick, we want to find that F shape, and I see some beautiful answers. Here is my lovely F. Remember, the corner of the F, that angle is always going to be equal to the angle just below it. And so we say, okay, cool, we know which angles are equal. X is equal to 73 degrees. Remember our reason, corresponding angles. And we always put in the parallel lines because in case there's a couple parallel lines, we always need to be clear which ones we're working with. AB parallel to CD. That's right. Right.
Yeah,
So we know
yeah.
that those angles are equal.